All right, in this section, we are going to use another algebraic technique to simplify radicals called completing the square. Hopefully you've seen this before in Algebra 2, and I think we've done this in pre-calculus as well. But a little reminder, when we want to complete the square, first off, we want to factor out the a, and we want to write this as a perfect square. So, for example, say we're starting with this polynomial 2x squared plus 12x plus 27. We're looking at the first two terms here, and since it starts with a 2, we're going to factor out a 2 from the first two terms, and that's going to give us x squared plus 6x. This thing is not a perfect square, but we can make it a perfect square by taking half of the coefficient here, usually we call this b, and we're going to take half of that and square it. So half of 6 is 3, 3 squared is 9, and we're going to add that to this thing. Now, this x squared plus 6x plus 9 is going to be able to be factored as a perfect square. But really what we added here was not 9, but 9 times 2. So we added really 18, and so we take care of that by subtracting 18 on the outside. And so 27 minus 18 is going to give us 9. And now we have it written as a perfect square, 2, and then this is a perfect square of x plus 3 squared plus 9. And we're going to use this technique in order to rewrite these integrals in this form or this form. And when we have it written like this, we're going to use inverse tangent. And when we have them written like this, we're going to use inverse sine. So this is going to be an inverse tangent problem. And we have 1 over x squared minus 8x plus 17. We're going to complete the square here. So let's just move this up. So x squared minus 8x, let's rewrite this here. So x squared minus 8x, and what do I need to complete the square here? So it starts with a 1x squared. We have negative 8 here. Take half of that, which would be negative 4. Negative 4 squared is going to be 16. And then we have plus 17 minus 16. Since we added 16, we have to subtract 16. So this is dx here. And now we can factor this guy as x minus 4 squared. 17 minus 16 is just going to be 1. And this is going to follow this form where we have u squared plus a squared. Let's write out what u is. U is x minus 4. Because that's the part that's being squared. Du is equal to dx. So whenever we do u substitution, make sure you find out what du is. And here there's no problem. And the a here, this is a squared. Well, 1 is already a square. So a is going to be just 1. Now we can rewrite this using the formula above. And if we want to, we can put this back into u form. So we have our u substitution, and we have this as u squared plus 1 du. And now we can take the antiderivative of it using this formula that we've used before. 1 over a. Since a is just 1, it's 1 over 1, which is 1. Inverse tangent of u. What is u? U is x minus 4. That's going to be in parentheses. And u over a, yeah, a was just 1 here, plus c. So we end up with inverse tangent of x minus 4 plus c. (29), same thing. We're going to do completing the square. So x squared plus 4x plus 8, not a perfect square, the way it's written. If you want to, you can complete the square underneath here. So x squared plus 4x. If you complete the square, that's going to be plus 4, because we take 4 divided by 2 is 2. 2 squared is 4. This is a perfect square. And then we have 8 minus 4. So I'm taking the 8 here, and since I added 4 to this part, I have to subtract 4. So we can rewrite this as 1 over this we factor as a perfect square, x plus 2 squared plus 4 dx. And now we're going to put u equals what? U is this thing squared, x plus 2. Du is just dx. A here, remember, the original formula looks like this. U squared plus a squared. So this is our u squared, this is our a squared. So a here is going to be 2. 2 squared is 4. And now we can use the inverse tangent formula. And so we're going to have 1 over a. A is 2. Inverse tangent of u, which is x plus 2. And over a, I should put over 2 here, plus c. So it's u over a, so we need to have x plus 2 over 2 plus c. And we've got our answer. (31). So for 31, we have 4x squared plus 16x plus 17. So we got to do a little bit more work with this one. Let's factor this a little bit. We can take a 4 out, and we can write this as x squared plus 4x. Leave a little space here. We're going to put the plus 17 on the outside. So I take the first two terms. I'm going to factor out a 4. I want this to be written as x squared plus 4x. We're completing the square on the inside. So take half of b. b here is 4. Take half of that, square it. That's what we have to add here. So half of 4 is 2. 2 squared is 4. But since that's in parentheses and we got a 4 on the outside, we really added 16 on the inside. To counterbalance that, we need to subtract 16 out here. So we can rewrite this as 1 over 4. And then we're going to have x plus 2 squared. And 17 minus 16 is going to be 1 dx. Here it's a little bit tricky because what is our u? Our u is going to be this part, but we want the square root of that. So it's going to be u is equal to 2, and then x plus 2. du is going to be, if we take this is 2x plus 4 really, du is going to be 2 dx. So dx here is going to be 1/2 of du. So now when we do the antiderivative, we're going to use again the inverse tangent formula. So we're going to rewrite this as 1 over u squared plus a here is going to be 1. And we're going to put a 1/2 out in front because dx we said was 1/2 du. So the dx we're going to place with a 1/2, which we put out in front, and we got our du here. And now we're ready to take the antiderivative. So we're going to have 1/2 out in front, inverse tangent of u. What was u? U was this thing. 2x plus 2 over a. A here is just 1. So we don't have to worry about that. We can put over 1 if you want to. Plus c. And that's what it kind of looks like. You could distribute this out as well. So you could put 2x plus 4 inside here. But this is the way I have it in the answer key. Okay, 33. Another example where we have to take out the a here. So let's factor this as 5 parentheses x squared and take out a 5 from that. That's going to be minus 8x. Leave some space. We'll put the 125 out here. We're completing the square on the inside. So negative 8, take half of that. That is negative 4 plus 16. And what did we add here? That's 5 times 16 is 80. So we have to subtract 80 from the outside. 1 over 5x minus 4 squared. 125 minus 80 is 45. The 45 though, 45 is not a perfect square, but 45 is 5 times 9. dx. So notice that we have a 5 here and a 5 here. We can factor out the 1/5 in front of the whole thing. So we can rewrite this as 1/5, taking out the 5 from both terms here, and factoring the 1/5 out to the front as x minus 4 squared plus 9 dx. And then we can just do u is equal to x minus 4, du is equal to dx. A is equal to the square root of this thing, which is 3. And we can do our inverse tangent rule. We've got 1/5, 1/3, inverse tangent. U is x minus 4 over 3 plus c. And then the 1/5 times the 1/3 is going to become 1/15 inverse tangent of x minus 4 over 3 plus c. So this one's the most complicated one because we can take out the 1/5 from both of them, from both terms on the bottom. All right, starting with 35, these are where we're going to use the inverse sine rule. So for the rest of these, we're going to use the formula for inverse sine. Notice at the beginning, I have the formula, which is the integral of 1 over the square root of a squared minus u squared du is equal to the inverse sine of u over a plus c. So we're going to try to set them up like this. And here, it's got the x squared at the beginning, and we're going to have to like rearrange it so it looks like this, basically. So again, we want to complete the square. And I'm going to take out a negative sign here. And again, I'm going to take it out from both the first term and the second term here. So let's take out a negative, and then we're going to have x squared plus 10x. And let's leave the negative 24 out here. So we're going to complete the square on the x squared plus 10x after I factor out a negative sign from both of these terms. And take half of b. Half of 10 is 5. 5 squared is 25. So I put a plus 25 inside, but that's really negative 25. And so since I subtracted 25, I want to add 25 to the outside. So I'm not really changing anything. I've introduced this positive 25, but it's multiplied by a negative sign, so that's negative 25. And so I add 25 to counterbalance. So it's going to be the same thing. We can rewrite this equation. We got 1 over the square root. And so it matches up with this form. We're going to put the constant first. So negative 24 plus 25 is going to be 1. And then we want minus sign. And then we're going to put this at the end here. And we're going to factor that. X squared plus 10x plus 25 is the same as x plus 5 squared dx. Now we have this looking sort of like this, where our u is going to be the inside here of x plus 5. Du is the same as dx, no problems there. We have a square at the beginning here, that's a squared. So what number squared is equal to 1? That's just 1. A is equal to 1. So now we've got it set up where we can use the inverse sine formula. So the antiderivative here is going to be inverse sine of u. What is u? Is x plus 5 over a. Well, a is just 1, so we don't really have to put x plus 5 over 1. We can just write it as x plus 5, but I'll simplify that here. And then plus c at the end. So we've got inverse sine of x plus 5 plus c for our final answer. Okay, the back here, 37, 39, 41, all of these on the back are going to follow kind of the same process. We want to rewrite it so that we can use that inverse sine formula. And let's look here. So this is underneath the square root. So that's probably a hint that we need to use inverse sine. It looks like we're going to have a perfect square. Let's see if we can get it to match up. We're going to take out a negative sign here. So it's going to be x squared We got the negative on the outside. This is going to be minus 8x. Close off our parentheses. Keep this negative 15 here. And complete the square on the inside. Take half of negative 8, which is negative 4. We're going to square that. Negative 4 squared is 16. So we added 16 inside, but that's really subtracting 16. So if we minus 16, then we want to add 16 to the outside. Now we can rewrite this, and let's put it in order. So the constant here is going to come first. That's going to be 1 again, minus this thing. We can factor. It's got a minus sign out in front, and it factors into x minus 4 squared dx. We can let u equal x minus 4. du is equal to dx. A here is the square root of this guy, which is just 1 again. And so we're going to end up with inverse sine of u, which is x minus 4, over a, which is 1, plus c. Let's see what happens with this one. So again, we've got a square root. It looks like it's going to be an inverse sine function. And we got negative x squared minus 6x. Let's factor it. We're going to complete the square, take out a negative. That leaves with x squared here. This is going to become a positive 6x. And leave some space, put a parenthesis, complete the square on the inside. To complete the square, take half of the b, square it. So half of that is 3, squared is going to be 9. That's really not 9 though that we just put in there, that's really negative 9. So on the outside, what do we have? Minus 5. And we just subtracted 9, so we have to add 9. Now we can rewrite this. 9 minus 5 is going to be 4 in the front. And this is all underneath the square root. 4 minus this thing, which is going to be x plus 3 squared when we factor this guy. So we rewrote this as this, dx. What is u? U is going to be this thing, the square root of it, which is going to be x plus 3. du is going to be just dx. A here. Here we have a squared is 4, so a is going to be 2. And now we can plug that into our formula. This is going to be inverse sine of u, which is x plus 3, over a, which is 2, plus c. And the last one, 41. Negative x squared, we got the square root of negative x squared minus 14x minus 33. So square root here on the bottom tells us it looks like inverse sine. We can use this, we can complete the square. We're going to factor out a negative sign. That leaves us with x squared plus 14x. Leave some space. Leave the constant out here. Complete the square on the inside. Take half of 14. That is 7. 7 squared is 49. We just subtracted 49, really. And so we're going to add 49 to the outside. And we're going to rewrite this. We got 1 on top. We got the square root. This part is going to be our a squared. 49 minus 33 is going to be 16 minus this thing squared. This is going to factor into x plus 7. That is dx. Do our substitution. Find out what u is. U is x plus 7. du is dx. A here, that's a squared, so a is 4. And we can apply the formula, which says it's going to be inverse sine of u, which is x plus 7, over 4 plus c. And that's it. So hopefully that helps. If you have any questions, let me know. Bye!